need to build an AA-powered product search that handles optional filters and default values automatically. You'll see how to define a search products tool with required and optional parameters, where FastMCP automatically generates the schema, validates inputs, and exposes it to AI models, all from a single Python function definition.
At MCP, tool, def search products, query, SDR hash required no default value. Max results, int equals 10, hash optional has default value. Sort by, SDR equals relevance, hash optional has default value. Category, SDR none equals none hash optional, can be none. A list dict is search the product catalog. Hash implementation.
This demonstrates the decorator-driven RPC pattern, where Python functions become remotely callable tools through declarative metadata. The @MCP tool, Decorator, transforms ordinary functions into typed, self-describing endpoints without modifying their core logic. What makes this distinctive is how it bridges Python's native type system with RPC schemas automatically, eliminating manual API boilerplate while preserving type safety. The pattern works by leveraging Python's introspection capabilities to extract function signatures, docstrings, and type annotations at runtime. These become the tool's schema, documentation, and validation rules, while the decorator itself handles registration with the RPC server. This separation means your business logic stays pure, focused on solving problems rather than managing transport layers, while the framework handles serialization, validation, and protocol compliance behind the scenes. This approach matters because it solves the impedance mismatch between Python's dynamic nature and RPC's strict contracts. You avoid writing repetitive root handlers, input validators, or open API specs by hand, yet still get strongly typed, discoverable endpoints. It's particularly valuable for AI integrations, microservices, or any scenario where you need to expose backend logic to external systems without coupling your code to a specific transport protocol. The trade-off is framework dependency, but the productivity gain for typed, self-documenting APIs often outweighs it. Let's break it down line by line.
At MCP, tool, def search products.
The @MCP tool decorator marks this function as an AI-callable tool in FastMCP. It automatically generates an open API-compatible schema from the type hints and docstring, exposing the function to AI models with full parameter validation. This is the standard pattern for creating tools that AI agents can invoke programmatically.
Query, SDR hash required no default value.
This parameter is required with no default value, forces callers to explicitly provide a search query, preventing accidental empty searches.
Max results, int equals 10, hash optional has default value.
This makes max results optional with a default value of 10. Callers can omit it, but the function still enforces a predictable upper bound on returned items, preventing unbounded result sets. Default parameters like this simplify the API while maintaining control.
Sort by, SDR equals relevance, hash optional has default value.
This parameter uses a default value pattern, making sort by optional while maintaining type safety. The default relevance ensures consistent behavior when callers omit the argument, eliminating the need for none checks in the implementation.
Category, SDR none equals none hash optional, can be none.
This parameter uses Python's optional typing with none as a valid value. The none union type explicitly declares that category can be either a string or none, while the equals none default makes it optional in calls. This pattern cleanly handles cases where filtering by category isn't required.
A list dict.
This return type annotation declares the function outputs a list of dictionaries, where each dictionary represents a product. It enforces type safety by making the expected return structure explicit, enabling static type checkers to catch mismatches early.
Search the product catalog.
This docstring defines the tool's purpose for AI models and documentation. It becomes part of the tool's schema, ensuring clear usage context in both code and generated interfaces.
Hash implementation.
This placeholder marks where the actual implementation would connect to the product catalog service. The function signature already defines the complete interface, so this section would contain the business logic for querying, filtering, and returning product results based on the specified parameters. FastMCP tool design pattern. The FastMCP tool decorator bridges Python functions and AI clients through automatic schema generation, where optional parameters with defaults create flexible yet structured interfaces. String inputs like 10 silently coerce to integers unless strict validation is enabled, which can mask data quality issues. Design your tool signatures to balance AI flexibility with backend precision.
The schema that appears to the client is the function that disappears from the code.